everyone, today I have an introduction to the definite integral. To begin, let's look at this in context of what we're trying to do. So this picture has the annual net income of Amazon from 2004 to 2020. I want you to think about, what does it mean by net income? Do any of these numbers kind of stand out to you, or do they surprise you? And because it's Amazon, I think the numbers that probably surprise me here are the negative 39 and the negative 241. Now notice this net income is in millions of dollars. So what does this say? This says in those years, Amazon's net was a negative number, so they really lost money. This is that their revenue didn't meet the cost that they had. So their cost was definitely higher in those years. Then you look at now, right, a little closer number like 2020, and it says the net income for that year in millions of dollars was $21,331 million. Let's look at net income over a series of years like 2012 to 2015. So we can see we had a negative 39 followed by a positive 274, then a negative 241 plus a positive 596. So we can put this together and see what was the total over those years. And that says the net income from 2012 to 2015 was $590 million. So we can kind of see these negatives and positives balancing out to get this total over that time. Let's extend that even more and say, what's the net income from 2012 to 2020? So here we had negative 39, positive 274, negative 241, positive 596, positive 2,371, positive 3,033, positive 10,073, positive 11,588, and then the 21,331 from 2020. It says in total, the net income from 2012 to 2020 was $48,986 million. So let's extend this a little more and take it back to things that we've talked about in this class, things like price. So here's a picture of a price function that is 2 minus 0.5x. And just looking at this picture, let's figure out the domain. So I have a domain of 0 to 4. And then my next question says, what's the area? Well, I want you to look at this and think about geometry. This is a triangle. So the area of a triangle is 1/2 the base times the height. So my base is our domain, which was 4. And the height, it's kind of looking at our range, was 2. So 1/2 4 times 2 just gives me an area equal to 4. Let's try that with profit. So here's kind of the profit looking at, sometimes it's negative, sometimes it's positive, and I really look like I have two triangles here. So I have this one below, I'm going to call this A, so it's below the x-axis. Then I have one that's above the x-axis, B. So this one below the x-axis, it looks like it's negative 20, and then it looks like it goes to 5. So for A, I have 1/2 of 20 times 5, which we're going to call 50. And just so it makes sense that it was below, we're going to call that negative 50, looking at that negative 20 there. Then to do B, think about, I'm starting at 5 and I'm going to 14, so that's 9. So I have 1/2 of 9. And then the height, we're going to guess and we're going to say that's 35. So this gives us 157.5. Now remember, to get the total profit, we're going to put those together. So I have 157.5 minus 50, and that's going to give me 107.5. So just like the one we looked at with Apple earlier, we put the negative along with the positive to get our net all together. So let's take that price we had earlier, 2 minus 0.5x, and let's turn it into revenue. So revenue is going to be x times p, so that's 2 minus 0.5x. I get 2x minus 0.5x squared. Now I'm going to graph that, and this is what it looks like. So this 2x minus 0.5x squared starts at 0, and it goes over to 4, and it hits 0 again, so we only want to take the revenue that's positive. And what if we wanted to find this area? What if we wanted to have like this net revenue that's represented? This becomes a little harder because in our previous example where we had just a triangle, it's easy to do 1/2 base times height, but for this, which is a parabola, we have to have another trick. So our trick is something called the definite integral. So let's walk through the definition and then we'll come back and solve that problem. So we're going to start with, if f is a continuous function over a closed interval ab, and this capital F of f is any antiderivative of f, then the integral. And notice there are numbers now. So I have an a and a b. So this is the integral from a to b of f of x dx is capital F of b minus capital F of a. Lots of new stuff happening, and this is only part one of, we'll be talking about this in the future. So this is just our quick introduction to the definite integral. But there is no c here, right? And that's why it's saying it's any antiderivative, because we're not having to worry about this plus c, because we're immediately going to subtract. So if we had the plus c, I would then subtract it and would go away. So I don't need the constant of integration now. I can just integrate. So we integrated from lowercase f of x to capital F of x, and now we're going to plug in the bounds. So these bounds, the top one goes first and the bottom one goes second, and it's subtraction between the two. I want to point out that the answer, when I get this f of b minus f of a, is going to be numeric. So it's not going to give us a function. This number that we're going to get is called the definite integral. So this is going to be equal to the area between the graph of f of x and the x-axis from a to b. So now we're going to have something that gives us area without us having to use geometry and go back to functions that we don't maybe remember or formulas we don't remember. So I'm going to revisit that, right? I'm going to go back to the ones we had, and we're going to use calculus. So here, this integral, I'm going from 0 to 4. Our function is 2 minus 0.5x dx. So to integrate, 2 gets an x, so now I have 2x. The 0.5, x was power 1, I'm going to make it power 2 divided by 2. We're going to put in 0 and 4. Let's pretty that up first. This is 2x. 0.5 divided by 2 is 0.25, and that's x squared, 4 and 0. So we're first going to put 4 everywhere. So I'm going to have 2 times 4 minus 0.25 times 4 squared. Subtract, I'm going to put 0 everywhere. 2 times 0 minus 0.25 times 0 squared. 2 times 4 is 8. 4 squared is 16. 16 times 0.25 is just 4. So this is 8 minus 4. 2 times 0 is 0. Negative 0.25 times 0 squared is 0. So I have minus 0 here. 8 minus 4 is just 4. And if we quickly looked back, we also got 4 when we did the geometry. So we just have a different way to get this area under the curve. So let's use that and try to find the area under the curve for the revenue. So revenue is going from 0 to 4 also. Our function is 2x minus 0.5x squared dx. So the 2x is power 1. I'm going to square that, divide by 2. 0.5, x goes from squared to cubed, divide by 3. 0 to 4. The 2's could cancel, so I have x squared minus 0.5 is like a half, so that a half times a third might be easier to look at. So I'm going to have x squared minus 1/6 of x cubed from 4 to 0. So I'm going to plug in 4. I have 4 squared minus 1/6 of 4 cubed. And then again, when I plug in 0, I'm going to get 0. But I will still write 0 squared minus 1/6 of 0 squared, or cubed actually. Okay, right, so I put in my calculator. 4 squared minus 1/6 of 4 cubed gave me 5.33. So we got a number, I rounded it. This would give me the total revenue from 0 to 4 of my revenue function. Let's talk a little bit more about the definite integral and the geometric interpretation. So we want to think about area as being positive, but when we're looking at this on a graph, what we're going to end up saying is everything above the x-axis is positive and anything below the x-axis is going to be negative. So we may need to split up our graph like I did earlier with the profit function and look at things positive and negative and what they're going to do and how they're going to work together. So I'm just going to do some where we're just looking at graphs and we're not actually doing any integration. As an example, in this figure, I have the integral from a to b of f of x. And notice I have area A under the x-axis, so we're going to call that negative A. And then I have an area B that's above the x-axis, that's going to be positive B. And we'll put those together to get the area overall between A and B of f of x. We would put negative A with positive B. Let's try some examples. We're going to use this figure that has 3 parts. So area A is 2.12, area B is 11.9, and area C is 7.67. To start, we're just going to find the integral from a to b of f of x dx. So when I look at a to b is the first part. So from A to B, it's the area A. A is underneath the x-axis, so when I give the answer, I'm going to say it's negative 2.12. So I need that negative to indicate the area is below the x-axis. For example B, I'm using the same figure, but I'm going to go from A to C. So A to B has the area A, B to C has the area B, so I'm going to have to put these two together. A, again below the x-axis, is negative 2.12. Then the area B above the x-axis is positive 11.9. That gives us an area of 9.78. So the negative comes away from the positive to give us our net area. C says go from B to C. So B to C is only the area B, which is positive. That would be 11.9. A to D has A, B, and C. So A was negative 2.12. B was positive 11.9. C is also negative, it's 7.67. Okay, that gives me a total of 2.11. So we have to remember to add the signs ourselves. The area are going to be stated as positive, and then we have to add the interpretation of above or below the x-axis to have the correct sign in front of the area. Last little bit is, what if I just give you this, that the integral from 2 to 4 of x dx is 6. So that you don't have to do the integration, I already did it for you. And I want you to calculate the integral from 2 to 4 of 3x dx. So what I want you to see is the only difference between the statement I gave you and then the answer I have is this 3. So I can pull that 3 out. And if I know the integral from 2 to 4 of x dx is 6, I can write in as 6, put the 3 out front, 3 times 6 is 18. Same thing, if I go 2 to 4 of 10x dx, take the 10 out, integral from 2 to 4 of x dx says this is 10 times 6, which is 60. We will do many more integrals in the future. We will do more definite integrals. We'll look at a lot more area. We'll add some application to it as well. So this was just our first introduction to get used to this new notation with bounds and to have the interpretation of what does an integral do? It gives us the area under the curve.